Hey guys, it's your boy Saksham Vashishta here, back with another calculus video. Today we're going to talk about parametric equations. Today we're also going to talk about how to graph them, as well as their notations, finding their derivatives, and using integrals to find different lengths of curves of parametric equations. Now, before we understand how to graph a parametric equation and doing all these cool fancy stuff, we have to understand what exactly a parametric equation is. Now, the textbook definition is a little bit complex, but let's go through it just for formality. Now, the parametric equation is a curve in the plane that is said to be parametrized if the set of coordinates on a curve, xy, are represented as functions of a variable called t. Now, this t is also called a parameter, and this is going to be very important later on in the lesson. Now, what exactly does this all mean? Well, it essentially just means this. A parametric equation is far more different than a traditional rectangular coordinate equation, where we have x's and y's. So a rectangular coordinate equation will look something like this.
Of y equals 3x squared plus 5x plus 3.
This includes x's and y's, but there aren't any t's. But a parametric equation actually has two different equations, one for y and the other for t. Now we can also notate this as y of t and x of t. And this is also represented like this. So if I were to have an equation of y of t is 4t and x of t is t squared, this is going to be my parametric equation. And to graph this, we're going to have to use a 3-column table rather than the traditional 2-column table of x's and y's, and then going on to graph it. Here, we're going to have to use t, x, and y, and then we can use these coordinates that we get in the x and y columns to then go on to graph in a function. So let's look at an example here. Graph the parametric equation x of t equals t plus 1 and y of t equals 2t. And t is going to be between 0 and 3. So the first step we want to do is set up the 3-column table.
So we have t, x, and y.
Now from here, we just want to plug in our values of t. And then x, we put in 0 right here, x of 0 to find x. So 0 plus 1 is going to be 1. 1 plus 1, well, that's 2.
2 plus 1, that's 3. And 3 plus 1, that's going to be 4.
We do the same thing for y. We plug in the t values into the y function, and we get the following. So now we have our 4 coordinates between 0 and 3 for t. And all that's left is just simple graphing. So here we can set up a graph.
Like so. And this is going to go from 1, 2, 3, 4. To 0, this is our x-axis, our y-axis. And I'm actually going to do it by 2s. That's just going to make it much more easier.
And now we just graph.
It's going to be 1, 0. So 1, 0 is right there. The next one is 2, 2. The next one is 3, 4. And the last one is 4, 3, 6.
So our graph is going to look something like this. And what I also want to do is I can also add these arrows to indicate the direction of the parametric equation. So that's how we can graph parametric equations. Now the next thing I want to talk about is removing parameters. Now this is going to be very, very important when it comes to graphing as well as trying to solve these equations as well. Now, removing a parameter essentially means that we want to remove the t, and we're actually combining the two equations together. And so what we want to use is just simple substitution to try to find what a simple rectangular equation is going to be for these parametric equations. So for this one, for example, we can find the rectangular equation very easily. We have to find what t is equal to. Now, we can find t really easily right here. It's going to be a little bit more difficult right here, so we can just do that right now.
Divide both sides by 4. And then our 4's cancel out. And we get x over 4 equals t.
Now what do we do? Well, we just have to substitute this t into the y function. And from here we get
y equals 8 And then the t here is going to be x over 4 squared. So now we just have to combine these terms. So x over 4 squared is going to be x squared over 16. And we can actually begin to simplify this. We can say this is 1, this goes in 2 times.
And the final answer is x squared over 2. So this is our final answer when we remove the parameters. So let's try it on this next problem set right here. X equals t squared minus 4 and y equals 3t squared plus 5. Now we solve for t again. So let's start solving for t on this one.
So we add 4 to both sides. X plus 4 equals t squared. And then you take the square root on both sides to get t
equals x plus 4. Now that we have what t is equal to, we can simply substitute into the y function.
And now we get y equals 3, the square root of x plus 4 squared plus 5. And we just have to simplify. This is 3 times, well, this square is just going to remove the square root. We're going to have left with x plus 4 plus 5. We distribute the 3, and we get 3x plus 12 plus 5.
And our final answer will be 3x plus 17. Of course, y equals 3x plus 17. Sorry. There we go. We removed our parameters. So let's try something a little bit more difficult. So in this one, we have x equals 1 over t plus 1/2, and y equals 1 over t squared plus 10. And so the first step that we can do to find what t is this. We first must recognize that we can also rewrite this x equation as x over 1 equals 1 over t plus 1/2. And now all we have to do is flip the numerator and the denominator on both sides of the equation. Now I'll show you why this works in a second.
This will be 1 over x equals t plus 1/2 over 1.
Now, if you still don't understand why this doesn't work, here's why. If we were to have 2 equals 4 over 2, which is a true statement, 4 divided by 2 is equal to 2, and we just rewrote this as 2 over 1, and then we flipped the numerator and the denominator on both sides like we did right here, we get 1 over 2 equals 2 over 4. And that's true. So we can apply the same thing right here.
And so now, all you have to do is just subtract 1/2 from both sides. We can actually, just write right here. I just forget about that. So it's going to be 1 over x minus 1 over 2 equals t.
So now we have the t value. And then we just substitute that in here.
So going on, we have y equals 1 over x minus 1/2 squared plus 10. And now we have to just simplify. So from here we get 1 over x squared plus 1 over 4 minus 2 times 1 over x plus 10.
So I forgot this is a 1/2 right here. So we can solve this.
So this 2 and the 2 cancel, and we're left with 1 over x squared plus 1 over 4 minus 1 over x plus 10. Now this part right here, will simplify to x squared plus 4 minus x plus 10.
That's just you're actually dividing by the inverse here, so we can just flip it back and get these values right here. And then we have, in the end, x squared minus x plus 14. And we have successfully removed our parameter. All right, let's go to the next portion of parametric equations. That's going to be differentiation of parametrics. So we have to know the two formulas for derivatives of parametric equations. The first one is going to be dy dx, so the change of the slope of a parametric curve. And that is going to be dy dt over dx dt, which means that we take the derivative of the x equation and also the derivative of the y equation, and then take the derivative of the y equation divided by derivative of the x equation to get dy dx. We're actually treating these kind of like fractions, and it just works out like that. For the second derivative, we have to take the derivative of the first derivative, so that hence the top part, and then divide all of that by dx dt. So let's do our example here. So it says x over 5 equals cosine of t, and y over 2 equals sine of t. So the first step is going to be to find the derivative of the x function and the y function. So let's first find the x function here, and isolating the x on one side.
So So we have simply just multiplied by both sides with 5, and then we find that dx dt is going to be 5 times the negative sine of t. Right here, we have our y function. We can multiply both sides by 2, and we get 2 sine of t. And then dy dt is equal to 2 cosine of t. We can rewrite this one right here. It's minus 5 sine of t.
Now, all that's left is to take this one and then divide it by that one. And then we get this.
dy dt, divided by dx dt, that equals 2 cosine theta, or t, divided by minus 5 sine t.
We can rewrite this as... So here is our derivative, dy dx. Now we have to make sure that we know this one because we also have to find the second derivative as well. So let's do that. So finding the second derivative requires us to find the derivative of the first derivative and then divide that by dx dt. Now we already know what dx dt equals. We saw that. That equals negative 5 sine t. And then we also know what dy dt equals. Or dy dx, I'm sorry. And that equals minus 2 over 5 cosine t over sine t. Or that's cotangent of t. But we're going to leave it like that, and you'll see why. Now, we already know that, but we have to find the derivative of this. So what is that going to be?
If you do the quotient rule. So, the derivative minus 2 over 5, all multiplied by this. So remember, it's low d high. So it's low d high. So it's sine of t times negative sine of t minus high b low, which is also cosine, all over low low. So let's start simplifying. So we have minus sine squared of t minus cosine squared of t all over sine squared of t. This can be reduced to 2 times fifth. And then we can factor the minus 1 out of it, and we're left with this equation right here. And we know that sine squared t plus cosine squared t is equal to 1. So we get negative 1 over sine squared t. And this right here is going to be very important. We can take out the negative 1, and we get...
And now we just take this. This is going to be our d dx of dy dx. That's the top part. And we're going to divide that by dx dt. And then we're finally left with the answer of 2 over sine of t with a negative outside. Or we can also be reduced to 2 cosecant of t. But the final thing that we must look at is arc length. So this is the equation for arc length. We take a L goes from the integral of t1, or the beginning t, to the ending t, all the derivative of dx dt squared plus dy dt squared. So let's do another example. Here we have this equation. We want to find dy dt.
First, because we have the dt, that's going to equal to 9 t squared plus 4t.
And then dx dt is equal to 5. And now all we have to do is plug it into the equation.
From 0 to 4, the square root of dx dt squared, 5 squared, plus 9t squared plus 4t squared dt.
And we can just simply use a calculator for this. This eventually gives us the answer of 227.393 units. So there you have it, parametric equations, and that is it. Thank you for watching this video, and subscribe if you're new.